Welcome to video 2 of the SQL Interview and Real World Query Masterclass. Today, we are solving one of the most common SQL interview problems, finding records that are missing from another table. In healthcare, the business request might be, find every health plan member who had no claims during 2024. A beginner often hears that question and immediately starts thinking about left join, not exists, or not in. A senior analyst begins somewhere else. First, define the population who is eligible to appear in the final answer. The complete population is the members table. Every enrolled member exists in members table, including members who have never submitted a claim. That leads to today's professional habit: think population first and syntax second. By the end of this lesson, you will understand how grain controls the query, how left join plus is null finds missing matches, why not exist is a clean anti-join pattern, and how one null can make not in return no rows. Let us begin with manager's request. Find all health plan members who had no claims during 2024. This sounds like a simple SQL question, but it's really a population question. Before writing code, ask who should be eligible to appear in the answer. The answer is every member in the health plan, not only members who appear in claims. This distinction matters because a member with no claim has no row in the claims table. If we start from claims, the people whom we are looking are already missing. Interviewers use questions like this to test whether you understand the business population, merely whether you remember an anti-join syntax pattern. So the first step is to identify two roles. Members defines the population and claims records the activity that may or may not exist. Before writing the query, define the grain. Grain means what one row represents. In members, one row represents one person. If the plan has 500 members, the members table contains 500 rows. Claim has a different grain. One row represents one claim. A member may have 0 claims, 1 claim, or many claims. Look at 3 examples. Member 1001 has 0 claims and therefore has no row in claims table. Member 1002 has 1 row claim and appears once. Member 1003 has multiple claims and appears multiple times in claims table. Now apply that population table rule, and the question is who has no claims? Start from members, because that's where everyone exists. Never start from claims for this question, because members with no claims are absent from that table. The professional habit is to say the grain out loud. One row in my result represents one member. Our first anti-join method is left join plus is null. A left join preserves every row from the left table. Since the members define the population, members must be on the left. SQL then looks for matching claims. Members with activity receives the claim ID. Members without activity receives null on the claim side. The result table makes the logic visible. Member 1001 and member 1004 have null claim IDs, which means no matching claims exist. The final where condition keeps only those null matches. This method is especially useful when you want to preserve the population and also inspect columns from the activity table during troubleshooting. The professional habit is simple. Left join keeps everyone from the left table. Is null identifies the missing matches. The second method is not exist. Instead of creating a join result, SQL asks yes or no question for each member. Does at least one matching claim exist? For member 1001, the answer is no, so the member is returned. For member 1002 and 1003, a matching claim exists, so they are skipped. Not exist is a clean anti-join pattern when you only need to test whether related activity exists. The subquery can use select one because SQL is not returning the value, it is only checking whether a row exists or not. Many experienced SQL developers prefer this pattern because the intent is explicit. Return the population row when no matching activity row exists. The professional habit is to use not exist when the business question is fundamentally an existence check. The third method is not in, and this is where SQL three-valued logic becomes important. The pattern looks simple, but a single null in the subquery can destroy the result. Imagine SQL evaluates member ID not in a list containing 1002, 1003 and a null. Under the hood, SQL evaluates a chain of comparisons not equal to 1002 and not equal to 1003 and not equal to null. The first two comparisons may be true, but any comparison with null becomes unknown. True and unknown is unknown, not true. So the row is not returned. This can cause the entire query to return 0 rows even though missing members definitely exist. The safe rule is to avoid not in unless the subquery is guaranteed not to return null or unless nulls are explicitly removed. In an interview, explaining this null trap demonstrates that you understand SQL logic rather than merely memorizing the syntax. Now let us compare the three techniques. Use left join plus is null when you want the population preserved and need columns from both sides. Use not exists when you only need to test whether a matching row exists. It is concise, null safe, and communicates anti-join intent clearly. Use not in only when the list is small or the subquery is guaranteed to exclude nulls. Otherwise, it's risky. For most missing record problems, left join plus is null and not exists are the professional defaults. The choice is often about readability and business intent, not about expecting radically different performances. SQL Server can frequently optimize equivalent anti-join patterns similarly. The practical recommendation is define the population and grade first, then choose the clearest safe method. Now let us apply the pattern to real healthcare query. The requirement is to find members who had no claims during 2024. We start from the members because it contains the complete population. We left join with claims and member ID. The 2024 date range belongs inside the on clause because it restricts which claim rows count as match. This is critical. If we put the right table date condition in the where clause, members with no claim would have null claim dates and would be removed, accidentally turning the left join behavior into the inner join. After the join, where claim ID is null keeps only members with no matching 2024 claim. The output contains members who exist in members but have no qualifying activity in claims. The professional habit is preserve the population first, constrain the right side activity in the on clause, then filter for the missing match. Now we are moving into SSMS to prove the missing record logic with the real healthcare tables. Our business request is simple. Return one row per member who had no claims during 2024. Before writing an anti-join, I want to validate two things, the population table and activity table. Members is our population table, claims is our activity table. And expected graying of the final answer is one row per member. First, I'm checking the members table. I want to know the total number of member rows and number of distinct member IDs. This tells me whether the population table is true, one row per member, whether duplicate member IDs exist. Next, I check claims. Here I compare total number of claim rows with number of distinct members who have claims. If claim rows is larger than members with claims, that is expected because one member can have multiple claims. This confirms that claim is an activity table with one-to-many relationship back to members. The difference in gray is exactly why we must think population first and syntax second. Now let us use the first anti-join pattern. Left join plus is null. The members table stays on the left because it defines the complete population. The claims table is on the right because it contains the activity we are checking for. Notice that 2024 date is filtered inside the on class. This is intentional. I want to preserve every member first, but only consider claim rows that fall inside the 2024 date window. After the join, member with no matching 2024 claim will have null in the claim side columns. The where clause then keeps only those rows where claim ID is null. These are the members who exist in population table but have no matching claims during 2024. This pattern is very useful when you want visually reason through the join and confirm which right side rows are missing. Now let us write the same business logic with not exists. For each member in the outer query, SQL asks a yes or no question. Does at least one matching 2024 claim exist for this member? If matching row exists, the member is skipped. If no matching row exists, not exist, because true and the member is returned. Inside the subquery, I am using select one. The number one itself has no special meaning. SQL Server only cares whether the qualifying row exists. Select one is simply clear convention that says, I care about existence, not about returning columns from this subquery. The member list should match the left join plus is null result. The syntax is different, but the business meaning is the same. Return members for whom no matching 2024 claim exists. Now I want to show very common mistake. This query still says left join, but the 2024 claim date filter has been moved into the where class. Think about unmatched member. About the left join, the claim side evaluates values are null. That means claim date is also null. When where clause evaluates whether null is greater than or equal to January 1st, 2024, that comparison is not true. That becomes unknown. And where only keeps rows where the condition evaluates true. So unmatched member is filtered out before claim ID is null. Condition can help us. This is why right side filters that define which activity counts usually belong to the on class. When the business requirement is to preserve the full left side population, the keyword left join by itself does not guarantee preservation if later where condition removes the null extended rows. Now we come to the classic not in null trap. I'm creating a small control list that contains member ID 1002, member ID 1003 and one null value. At first glance, you may expect 1001, 1004 to be written because they are not explicitly listed. But watch what happens. We get no rows. Here is the logic under the hood. Conceptually, not in behaves like a chain of inequality checks connected with AND. For number 1001, SQL is effectively asking 1001 not equal to 1002 and 1001 not equal to 1003 and 1001 not equal to null. The first two comparisons are true, but any null comparison with null becomes unknown. So the overall expression becomes true and unknown, which evaluates to unknown. And again, where only written rows where the predicate is true, unknown is filtered out. This is why a single null in the not in subquery can poison the result. Now I explicitly remove null from the subquery. Now the expected missing members can be returned. The professional takeaway is not that not in always wrong, The takeaway is that you must control null behavior. For anti-join problems, not exist is usually the safer and clear default. Finally, I do not want to assume the two methods are equivalent just because they look equivalent. I want to validate them. I create one result set using left join plus is null and another using not exist. Then I use except in both directions to find any member ID that appears in one result but not in other. If this returns no difference rows, that is strong evidence that both methods produced the same member set for this business rule. This is a professional habit worth keeping. When two query approaches are supposed to be equivalent, compare the result sets instead of relying on visual separation. So from this demo, we have proven 5 things. First, define the population and the grain before writing the anti-join. Second, left join plus is null works when we preserve the population correctly. Third, not exist express the missing match position very directly. Fourth, placing the right side filter in where can destroy the preservation behavior of a left join. And fifth, not in can fail when null enters the subquery result. Now let us return to the slides and turn these examples into a simple decision rule you can use in interviews and real projects. This decision tree gives you repeatable interview framework. First ask, do I need to find missing records? Next ask whether I need columns from the right table. If yes, left join plus is null is often the clearest choice. If no, not exist is usually the cleanest existence test. Regardless of the method, always begin with the most important question: which table contains everyone eligible to appear in the answer? And remember the warning, avoid not in when the subquery can return null. This is how senior developers choose an anti-join pattern. They do not start with syntax, they start with population, green, and business need. Let us close with 4 takeaways. First, define the population. Start from the table containing everyone eligible to appear in the answer. Second, say the grain out loud. One row in the result should represent one member, one provider, one customer, or any other business entity. Third, use safe anti-join patterns. Left join plus is null and not exists are reliable professional defaults. Fourth, respect null logic. Not in can fail when the subquery contains null. The signature professional habit for this lesson is think about the business question first. SQL syntax comes second. Think about the business question first. SQL syntax comes second. That mindset will help you solve missing record questions correctly in interviews and in real production analysis.